Today on Capechi's Corner, we're going to look at solving polynomial equations. So this first chart is going to be helpful, as you look at factoring, different factoring techniques. Depending on how many terms you have, you're going to have depends on which method you could use. So with any number of terms, greatest common factor is always, always, always the first thing you look at. If you have two terms like a squared minus b squared, or you have some cubes in there, there are the methods you can use. Difference of two cubes, and then we have, difference of two squares, and then we have sum and difference of two cubes, which we're going to look at today. If you have three terms, that's what we're most familiar with. You can use, see if there's a perfect square trinomial, or just general factoring. We're going to just, you're going to use a lot. The other method we're going to look at today is factor by grouping, and that's four or more. Anytime you have four terms or more and you cannot combine them, any like terms, then it's definitely grouping is what you're going to look at. All right, so let's talk about some sum and difference of cubes. Okay, so there's two patterns. We have a cubed plus b cubed, and we have a cubed minus b cubed, and you could see the result is very similar except for the sign. So there's two ways you can look at that. You can say, when I factor it, I'm only ever going to have one negative sign. It's just a matter of where the negative sign is. If you start with the plus, then you start with the plus, and then your negative sign is here. You start with a minus, and then you start with a minus there. That's one way to look at it. Another thing that I've seen other teachers use is use something called SOAP to help them, meaning when you factor it, same, opposite, always positive. So what that means is, for instance, in this negative, it's going to be the same, right? This is negative and this is negative. My next sign is opposite, right? And this sign, regardless of how you're doing, is always positive. So that might be helpful to you as well. So let's look at our patterns. The first thing I'd like to do here is I'm going to factor. And I do have a perfect cube minus a perfect cube. That's the only time it will work. So my a value in this case is going to be n. And my b value, the cube root of 64, is 4. So that kind of helps us with our pattern. So I'm going to use the same sign. So I have n minus 4. And then if you look at my pattern, again, I'm talking about this one here, but they're similar. A is going to be squared, so that's n squared. My sign's going to be positive. I'm going to take a times b, which is 4n. And then I have b squared, so it's going to be plus 16. And that's it. Okay, let's look at our next example. Now, moving on, I don't just have a variable here, I have a number in front. So my a value here is going to be 2x, and my b value is going to be 3y. So I'm going to be careful when I factor. Okay, so I'm going to have a plus b, so I'm going to have 2x plus 3y. And then I'm going to square it, and I have to square the entire thing. 2x squared is 4x squared. The mistake people make is sometimes they square the x and not the number there. So that's 4x squared. Now here comes my minus, and I'm going to multiply the two of those together, so I get 6xy, and then always positive. And then my last term, 3y squared, is going to be 9y. So there is the factor of that. I'm sorry, now my squared. I forgot the square there. Okay, let's move on. Let's look at number 3. Now, with number 3, this is a perfect square, right? AY cubed is a perfect square, but the problem is with this term right here, that 5 is not a perfect cube. So this can't be factored. Can't be factored. So you just have to be careful that both terms, the coefficients and the variables, have to be factorable. Sometimes that people call that prime polynomial, meaning that you can't factor in anymore. All right, let's look at number 4. Now, the different thing about number 4 is this coefficient here is negative. So we want to see, we have two terms. We want to see, again, we need to take out a greatest common factor there. So before I get started, I can take out a -2. I like that leading coefficient to be positive. So both coefficients are even, so I can take out a 2. That's the highest number I can take out. And I'm going to take out a -2. Now, when I look at my variables, I have w to the 7th and z to the 6th. So I can't take out anything except for just a w. I have negative 250w, and then z to the 6th. So I can take out 1w, but that's it. So I'm left with 27w to the 6th plus 125z to the 6th. Okay, now the question is, can I factor that further? So I have negative 2w. This is a perfect cube, and that is a perfect cube. So my a value here is 3w to the 2nd, and my b value is 5z to the 2nd. So I have to be careful. So my first term, I have, I'm just going to have a plus b, right? So I have 3w to the 2nd plus 5z to the 2nd. Now I'm going to have 3w to the 2nd squared. So it's going to be 9w to the 4th. Again, you have to be careful there. And then there's my negative. I'm going to multiply those two terms together. So that gives me 15w to the 2nd, z to the 2nd. We always put it alphabetically. And then my last term squared is plus 25z, and then z squared is 4. So I have 3w squared plus 5z squared, and then I have 9w to the 4th minus 15w squared z squared plus 25z to the 4th, and I have to remember to pull that out and rewrite that as well. Okay, so that's using the cubic. So again, you have two patterns very similar except for the signs. I find pulling out this A and B first, I find that to be very helpful, especially when you're new at it. All right, let's look at factor by grouping. And it's exactly as it sounds. We're going to group some things. So we're going to start with 4 terms. So basically, you're grouping these together and these together. And it really is about taking out a greatest common factor. So here's the pattern. I know if you can see this, that what is going to be in our parentheses should always be exactly the same. That's kind of our goal. And we'll go from there. Okay. So I'm going to group them together. Just underlining them sometimes helps. In that first group, my greatest common factor is 2x to the 2nd, and I'm left with x minus 4. I look at my second group, and I'm going to take out a 3. So it's going to be plus 3. I need a sign there, either plus or minus, and I'm left with x minus 4. Now, if you can see this, this should always be the same. If it's not the same, then a couple things happen. Either you needed to you made a mistake along the way, you took out something that was incorrect, or maybe that polynomial can't be factored. So you just have to be careful about that. So if you look at this, I have two terms, right? I have this one here separated by a plus and that one here. So what is the greatest common factor? The greatest common factor is that x minus 4. I'm going to put that up front. And then what am I left with? Well, I am left with 2x squared plus 3. Okay, now a lot of students ask, does it matter which one you put first? Like, is it okay if I put that first? Yes, it's fine because you're multiplying. But the idea is this term right here, this one up front, is your greatest common factor. So we usually list that one first. Okay, let's look at our second one. Again, I'm going to kind of underline what I'm going to try to group together. So my first grouping is just x squared is my only greatest common factor. I'm left with x minus 4. Now, if you look at the second grouping, I can factor at a 9. So I'm going to show you what happens. So that would give me negative x minus plus 4. Okay, so at this point, can you see we're going to have to make an adjustment? So you see how this is not exactly the same as that? That's a 4. You see how it's not exactly the same? Similar, but the sign's off. So what that means is this is my goal. I'm trying to get the x minus 4. So what I'm going to do here, I'm going to back that up. And instead of factoring out a positive 4, a positive 9, I'm going to factor out a negative 9. And that gives me x minus 4, which is what I want. So again, you'll get better at those with more practice. So x minus 4 is my greatest common factor, and I have x squared minus 9. Now, if you notice here, this x squared minus 9, that's factorable, right? That's a perfect square minus a perfect square. So I can pull that out and break that down a little bit more. So I have x plus 3 times x minus 3, and I have to remember to rewrite that x minus 4. So that's your final answer right there. Okay, let's look at now we have we have more than just 4 terms. So remember we said factor by grouping is 2 or more. So let's see what we have here. It looks like I have 6. So I'm going to pull this out and group that together, and then we'll see what happens. We can always adjust it if we have to. Okay. So in the first one, my greatest common factor looks like it's a 4x, and I'm left with 2a plus b plus c. Now, same thing. It looks like in my second grouping there, I can factor out a 3y. So I'm left with 2a plus b plus c. So again, I can go back and look, and I notice that my grouping there in the parentheses is exactly the same, which is what I want. Now, although that is my greatest common factor, a lot of times we're going to put this 4x and the 3y together. So you usually see the binomial first, whatever the term is, whatever the polynomial is with the least amount of terms is usually listed first. So I have 2a plus b plus c because that's my greatest common factor. And that's my final answer right there. Okay. Now let's look at number 4. This one's going to be a little different. If I pull this out here and pull this out there, let's see what happens. Okay. Well, I have just an x. So that gives me a cubed x minus b cubed x minus 6a cubed. And if I look at my second set of terms, I can only take out a 3, right? So I get a 3, and I'm left with a cubed plus 2b cubed x minus 3b cubed. So if you notice in this one, and I did it on purpose, this does not match this, not even close. And if I go back, it's not that I made a mistake. It's just this time the groupings are not just listed nice and neat. So I'm going to erase that. And I'm going to go back. And this time I'm going to take a look at my terms and see what I have. It looks like I have some X's in some, but not all of them. I have some A's in some and B's in some, not all of them. So if I kind of play around, I notice that I have an A in this one, in this term, and this term. And I have a B in this term, this term, and this term. So I'm going to try that. I'm going to try something different. So if I just look at what I underlined in red, what I have, where I have the A terms, I can actually factor out an A cubed. And I'm left with x squared minus, that gives me 2x. And that final term gives me plus 9. Oh, not 2, it's a 6. Sorry, this is a 6. X squared minus 6x plus 9. Now I'm going to do my B. And if I start with this one, see it's a negative. I'm trying to get that positive x squared. So I'm going to see what happens if I take out a negative b to the third. And I'm left with x squared. Now looking at this term, I have minus 6x. And this last term would be plus 9. So when I do that, I notice that I'm in good shape because those trinomials are exactly the same. Okay, so I'm going to rewrite. I have a cubed minus b cubed, and then I have times x squared minus 6x plus 9. Now this has a lot of factoring we can do, right? This is a perfect cube minus a perfect cube. So this becomes a minus b, and that's a squared plus ab plus b squared. And this last trinomial, we can see if we can factor that as well. And that gives me x minus 3 and x minus 3. So they are exactly the same. So I can pull that one out front. Doesn't really matter. X minus 3 squared. And then I have times a minus b times that trinomial a squared plus ab plus b squared is my final answer. That's a long one. Okay. All right, let's look at our last two problems. This time we're going to solve. Now, again, how do we know we solve? We always go through this in all levels of math. These directions on this first say factor, and there was no equal sign. Okay, so we get to this last set of directions. It says solve, so we know. Remember, solve in math means get whatever variable is by itself, and also there's an equal sign in the original problem. Okay, so let's factor. So I don't have a greatest common factor, so I have a trinomial. I'm going to try to set that up. So x to the fourth, I can do x squared and x squared. My signs are going to be opposite. I'm going to have a plus and a minus. Factors of 90. I'm going to do 10 times 9. My 10 has to be attached to the plus because that's the higher factor. And my middle sign there is a plus. Okay, so because of that, either x squared plus 10 is equal to 0, right? Because the zero product property, because they're both equal to 0, or x squared minus 9 is equal to 0. So from here, we have to solve. X squared, I'll take that 10 to the other side, take the square root of both sides, and x is equal to, remember, whenever we do that, it's a plus or a minus. Now, negative 10 becomes I root 10. And when I do the same thing with this other equation, bring 9 to the other side. I'm ahead of myself a little bit there. Take the square root of both sides, and x is equal to plus or minus 3. So my final answer is x is either equal to 3, negative 3, you could put them together if you want, or plus and minus I root 10. And again, you could separate those if you wanted to. All right, let's take a look at the next one. Now, this is a perfect cube plus a perfect cube. So my a value is going to be x, and my b value is going to be 6. So that gives me x plus 6. And I multiply that by x squared. Here's my minus. Multiply them together. I get negative 6x and then plus 36. But remember, I'm solving, so that equals to 0. So either x plus 6 is equal to 0, or x squared minus 6x plus 36 is equal to 0. All right, this first one's easy, right? This is x is equal to negative 6. Now, the second one is not factorable because I would be looking for factors of 36 that when I add them together, I get 6. I'm not going to get anything, okay? So it's not factorable, so we're going to actually have to use the quadratic formula on this one. Okay, so our a value is going to be 1, b value is equal to negative 6, and the c value is equal to 36. So I have x is equal to negative b, which is going to be positive 6, right? Plus or minus b squared. So it's going to be negative 6 squared minus 4 times a, which is 1, times c, which is 36, all over 2 times a, which is 1. So we're going to keep working on this one. It's going to take us a little bit of work. 6 plus or minus. And then when I put all of that together, I end up with negative 108. You can use your calculator for that. Just remember this right here is always going to be positive. Okay, so I have negative 108 all over 2. So I'm going to break up that negative 108. Okay, so that's going to be 6 plus or minus. So I need that, pull that negative 1 out. I get the square root of 36 and the square root of 3 all over 2. So I get 6 plus or minus. Square root of 36 is 6, and I have that negative 1. So it's going to be 6i square root of 3 all over 2. Now, if you see everything here, these terms here, this is divisible by 2, so is this, so is this. So I can divide a 2 out of all that. So my final answer there is going to be x is, get back my drawing tool, x is equal to 3 plus or minus 3i root 3, and then you'll have a 1 on the bottom. So my final answer, don't forget about that x is equal to negative 6 up here, or this answer right there, 3 plus or minus 3i root 3. Okay, that's it for today. Great job. Thanks for stopping by.